Hello, class. This recorded lecture is going to focus on domains of equations. And it actually will be domains of equations that are functions. Again, we're still in section 3.1. When we get to 3.2, I'll explain how you figure out if an equation is a function. It's something called the vertical line test, and the best way to do it is to graph it. But before we do that, we're going to continue our discussion on domain. And history has shown domain is a concept that sometimes it's hard for students to grasp this idea of domain. And the idea of domain is you first need to know what set of values or numbers that we're dealing with. And we've talked about real numbers, and we've also talked about complex numbers. So in this lecture and during our discussion right now, we're talking about the real numbers. So if the answer is complex, that's not part of the real number line. So that would mean that it's not a valid value. So before we take a look at some equations, let's look at some conventions on how to describe this. The first thing to look at is the number line. And remember that the domain are all the values of x. And so if this is the number line of x and this is the number 0, this arrow means that we go all the way out to positive infinity, right? And this arrow means we go all the way to negative infinity. And with regards to convention on how to indicate in a mathematical way what are the valid values of x, there's a couple ways to do it. My personal favorite, and because it follows this number line idea, is what's called the interval format. And so with the interval format, the way that that is structured is that you have two endpoints typically. And so in this case, the parentheses imply that the endpoints aren't included. So the endpoints not included. And when we use brackets, that implies the endpoints are included. And so when we indicate that, you think about how the number line works as well. It's, at least in my mind, it works the best. And so this is the format that we will be focusing on throughout the semester. I will be using this when the quizzes and the exams. I'd like you to use it on that as well. So this is a good one to get very familiar with. So the first thing is that what are the whole number line would be all real numbers. So it'd be from minus infinity all the way to positive infinity. So one thing in the math world that we have to keep in mind is infinities are not numbers. So when we indicate something that looks like this, that means that whenever you have infinities, you always want to use the parentheses because it's a concept that it goes all the way out to forever. Positive infinity goes to the right on the number line and negative infinity goes to the left. So this indicates all real numbers. So if we took a look at, for example, I took just part of the number line. So say like I started at 1 and I went all the way to infinity. And since I've closed this closed circle or a dot, that means that the number 1 is included. So how do you describe that in an interval format? It would be a bracket 1 all the way to infinity. If we had an open circle there, for example, it looked like this, or that's the number 1. The open circle implies the endpoint is not included. So that would be parentheses, and then infinity always has parentheses with regards to that. Let's do a couple more. So say like you had this. Say like that was -5. And say like we stop at +6. So those are the number line that we're dealing with. So the open circle implies the -5 is not included. So that would be a parentheses -5. And you could see the closed circle implies it does include it. So it would be 6. So one other thing, and this is a little bit tricky, but I think you'll get the hang of it when you practice it a little bit. How do we combine if something looks like this? Say like we're starting at -infinity, right? And say like we go all the way up to the number -2. And say like there's a break. And then say like we start again at 3. And we go all the way up to say 7. How do we indicate that in an interval format? Well, the way to do it is to do each part, and then we need to combine it together. So this part here is -infinity to -2. And we'd have a bracket because the -2 is included. And then we have this side, right? Parentheses 3, and then 7 is a bracket because 7 is included. So how do we combine this? Well, the way we combine this is this U, which stands for union. If you remember a little bit about set theory, we combine those two sets together, and these are sets. So in the math world, we indicate them as sets in this interval format. So you'll see in the homework, you'll get a chance to practice some of this. And so what I'm going to do now is we did domains and ranges in the first lecture where we talked about functions in ordered pairs, right? Just points. So now we're going to expand it to equations. And we're not going to do ranges yet. And to calculate a range of an equation, the best and easiest way to do it is to sketch it. And you'll see that the same thing is true if you want to take an equation and see if it is a function or not. And again, we'll talk about those a little bit later. So say like we had this equation, y equals x squared plus 5. So the strategy that I use when I take a look at an equation is I ask myself, what is the set that we're dealing with for the x values? Well, in this case and throughout this section, it's all real numbers, not complex numbers, just real numbers. And so I ask myself, if I plug a real number into the equation for x, do I get a real number for y? And so if you think about it, are there any bad numbers? In this case, the answer is no, because no matter what number you plug in, out will, for x, out will come a real number or the answer for y. So you would say that this one is -infinity to positive infinity, which indicates all real numbers. The other thing, there's two things, especially in this class, that we want to avoid. Number one is you don't want to divide by 0. You can't divide by 0. It doesn't give you a real number. It doesn't give you a complex number either. It implies infinity. And the other thing is that we can't take the square root of a negative number. again, that gets us into the complex plane instead of the real plane. So let's take a look at a couple of those. So say like we take a look at this example, 3x over x minus 5. So you say to yourself, okay, well, up in the denominator, I could put any number in for x and nothing weird's going to happen, right? Not divide them by 0, since we're in the denominator, right? And there's no square root, so we're in good shape. But what about in the numerator? Well, in the numerator, if I plug in x equals 5, that implies that we would get 15 over 0 when you plug that into the equation, and you see that doesn't work. So the way to think about this is like, if you think about the number line, right? And say there's the origin. What happens at 5? Well, what we need to do at the number 5, let's get out our little eraser. Oh, that didn't work, right? What we need to do is we have to put a little circle on the number 5 because the number 5 here is excluded. And so to generate the interval format, again, these two ends are infinity and minus infinity, right? And so we have to break up this 5. So the 5 goes there and the 5 goes there. And then you put a union here. So what that indicates now, and I need commas here. So what that indicates now is that's all real numbers except the number 5. So let's do a couple more. Say like you had this equation, y equals the square root of 4 minus 3x. So now you say to yourself, okay, what do I do with regards to the square root? Well, you know that you can't take the square root of a negative number, but you can take the square root of any positive number. Remember, square root of 0 is also 0, so that's okay as well. So the way to do this calculation is you want what's inside the square root sign, right, to be greater than or equal to 0. So if you do this calculation here, what I'll do is bring the minus 3x to the other side. So it'd be 4 is greater than or equal to 3x. And so if we divide each side by 4, we get 1 is, whoops. Why are we dividing by 4? I want to divide by 3. So you divide each side by 3. Sorry about that. You want to make the value of x be 1, so those cancel. And you would see x is less than or equal to 4 over 3. So this equal sign means that this point is included. So if you get out your number line again, and I always like to look at the number line, is that if this point here is 4 over 3, all right? And x is going to be less than or equal to that. So that means we go to the left, right? And so we would go down all the way down to minus infinity here. So the solution would be minus infinity all the way up to 4 over 3. And when you do that, the endpoint is included in this case. And so we have a bracket with regards to that. Okay, so let's do one more. I think this one is probably the most complicated, and so it's a good one to end with. And if you got a good feel for this one, excuse me, I think you'll have a pretty good feel for what we're trying to do here with regards to domains of equations. Okay, so look at this craziness. So now we're actually combining both problems. Problem number 1, you can't take the square root of a negative number. Problem number 2, you cannot divide by 0. So let's take the bottom one first. That one's usually a little bit easier. So in this case, we have x minus 5 cannot equal 0, right? And so x cannot equal 5. So that's one bad point. X equals 5. Because if you plug 5 in, you see you would get 0 on the bottom. Let's just do that real quick. So if you plug 5 in, you would get 0 down here. And so that would be square root of 20, right? 15 and 5 is 20. Not a real number, so 5 cannot be in our domain. So what do we do on the top? So what we'll do on the top is we want 3x plus 5 has to be greater than or equal to 0. So when you solve this, you would get 3x is greater than or equal to minus 5. And so if we divide each side by 3, x would be greater than or equal to minus 5 over 3. So how do we set that up? Well, I always like to do the number line and then work our way through. So where are we starting? Well, x has to be greater than minus 5 over 3, right? So our lowest one is minus 5 over 3, right? And there's a closed circle or a dot because the equal sign means it's the endpoint's included. And so we want to go all the way to infinity, right? Because greater than means we're going to the right. So we're going to go to positive infinity. But we have to put a hole in where this 5 is. So you put a hole right here at 5. And then you keep going all the way to infinity. So how do we indicate this in the interval format? Well, this endpoint's included, so it's minus 5 over 3. But then we have a break at 5, and that would be a parentheses. And then union, or start again at 5, but not included. And then we go all the way to infinity. So this is the recorded lecture for domains of equations. And I think this is a good place to stop. And we'll continue some more recorded lectures on section 3.1.